morning. Engineering 2. Let's wrap up with the dimensioning. So I think I've been trying to finish this for a while. All right. So, and again, many of these I can already cover. It's just something that we're going to try to do quick. If you guys recall, I told you I don't want any dimensions inside of the part. The dimensioning, the first line of dimensions should be 3/8 away from the part in both sides. The next dimension should be about 1/4 of an inch spacing on both sides. All the text should be horizontal. It's like this. It doesn't matter what view you have. The text should be horizontal, just like the way it looks right now. The exception of closing the part would be when you have a leader. You are pointing to the hole, so you will have the hole. The hole doesn't go all the way inside the part, right? It has to go towards the center of the bullseye and then away from the bullseye. It's like that. If you go and you give me an arrow that looks something like this, that is bad. The gap for the extension lines, which this is the extension line, that one is extension line, this one is extension line. They should be about it's called about a 16 of an inch. The gap outside, this gap, the one outside, it is about an 1/8 of an inch. Now, in you guys' case, I'm not going to be dimension any of this. So if you are really close to it, I'm going to call it good. But if you go and you exaggerate any of these dimensions, like instead of giving about an 8, you give me like 3/8 or a 1/2 inch for that dimension, I will notice it right away. That will be like too long. Let me see what I am. I believe we are here. We already covered that one. I believe we covered all of these ones. The arrowheads, as I previously told you, is a 1 to 3. Right? So 1, 2, 3. The length of the arrow, it is about 1/8 of an inch. So I think that's it. You guys see approximately the 3 times as long as they are wide. So it's a 1 to 3 ratio. Right? The leaders, as I previously told you, they have to go towards the center of the part and then away from the part. This is incorrect in power practice. So I will be looking at that. When you dimension drawings on inches, we have a couple of rules, and one of them is no leading zeros. So you guys can see here, there's no zero. This number here is less than 1. There is not a 0 in the front. There is not a 0 in the front here. There is not a 0 in the front here. The dimension is expressed to the same number of decimal places as its tolerance. What do I mean with that? When you go and you fabricate a part, you have some leeway. You give the leeway to the manufacturer. So when they do it, how do I do this? The thing is flipped. Like that. Sorry for the camera. I don't know. The camera. Sometimes when I put the text helps a little bit to get the resolution. Let me change the resolution manually. It's the best I could do already. Okay, this is not going to work. Let me do it on this one. All right. So sometimes when you go and you build something, let's say something like that, your part is not going to be perfect, right? Doesn't matter what you do, you can model it on the model, and the model is going to be perfect. But in reality, it won't. When they actually get to build it, there will be some leeway, right? And the leeway for them to have a size, for them to manufacture the size, let's say this is the bigger it can get. I mean, the smallest it can get. This one is the biggest it can get. So you give them a range, okay, of how much the part could be manufactured to this little space, what we call it the tolerance. So, how much you give the manufacturer for them to do the work. Depending on the application, you are going to put some tolerance, depending on what the function is going to be. For example, if it were to be for aerospace, most likely you're dealing with thousandths of an inch to 10,000ths of an inch. 0.001 to 0.0001. And again, you can also be welding on a welding shop. Your plus and minus being there probably like a 16 of an inch, right? Which is much larger, is 0.06. like 60,000ths of an inch. Now, depending on the function, you want to apply the tolerance. It's going to be the leeway. So, for example, if in your drawings I go and I tell you that you need to put a tolerance that is plus minus 0.15, that means I got 15 thousandths of an inch and my part can vary in size plus 15 thousandths minus 15 thousandths. In other words, if this guy were to be, I put it on the drawing and my drawing were to say 1.000, the biggest I can get will be 1.000 plus 0.015, and the smallest I can get will be 1.000 minus 0.015. So as you guys could see, it could grow and I can decrease in size, and I do that such that things get to be manufactured. The little leeway that you give to the machinist is what we call a tolerance. So you guys will notice that it tells you there in the rules, a dimension is expressed to the same number of decimal places as its tolerance. So if your notes, if someone in your notes and I give you some notes and I tell you to add it to the drawing, and the drawing tells you plus minus 0.015, that means you have 3 decimal places, and everywhere when you put a dimension on the drawing should have 3 decimal places. Decimal places here, 3 decimal places here, 3 decimal places here. Now if I tell you 2 decimal places, maybe I tell you 0.02, then you will put 2 decimal places. Hopefully that makes sense. No leading zeros and the same number of decimal places as your tolerance. Millimeter dimension is a little bit harder. It has more rules. It has one extra rule. And for tolerance, it's even harder. For dimensions themselves, without any tolerances, if you were to have a whole number, like 4 millimeters, 20 millimeters, 15 millimeters, you don't put any zeros. Just put the number. Boom. If you were to have a number that is less than 1 millimeter, you guys will notice that you will put a 0. So the millimeter drawings, the SI system, and actually you have to put the leading zeros. And keep in mind that we don't have trailing zeros. It's a little bit different, okay? In fact, if I were to put this in perspective, and I don't know if my thing is going to work anytime. Sorry for the technical difficulties, guys. We wanna work on that later. Okay. So if I were to look at the, let's call this guy the Imperial system. And again, sorry for the text, Imperial. Maybe I should connect my tablet. That way I can write a little bit better. Just give me a second. Let me just connect my tablet to my computer, and then we can do this much better. That way you guys can understand my text. Okay, connecting right now. Boom. Then you should see what I write much better. It's coming its way. Yes, it's gonna work, or we're gonna spend all the time here thinking about it. I think it is. Okay, connected. So this is what I was telling you guys. If I were to put the Imperial, let me erase this mess. The Imperial, and again, the Imperial is the US system. And if I were to do the international, which again, the international is the millimeter system, or sometimes they call it SI for international system or units. If I were to look at this, let's say that I give you one here, the units will be inches, right? When you put it on the drawings, it will be based on inches. If I were to do it on SI system, your drawing will be on millimeters. If I were to do 1.00, let's say that I give you in your drawings plus minus 0.015, in the Imperial system will be really easy. If I were to have something that looks bigger than 1, maybe like 3 inches or something, 3.125, right? So you put 3 decimal places. Easy peasy lemon squeeze. If I were to be less than 1, you will not put the 0 in front, and you will still put 1 to 5, so it's 3 decimal places. So nothing too bad. In the Imperial system, though, the SI system is a little bit harder, because if you were to put a number that is whole number, like 3 millimeters or 4 millimeters or 5 millimeters, you will have to just put the 5 or the 20 millimeters or the 10 millimeters. If I go and I tell you you have a tolerance of 0.15, and you have 2 decimal places, and you have a dimension that you gotta do, and let's say this one is 0.1 millimeters, you will only do 0.1. Why? Because you are not supposed, actually 0.1. Why? Because you have to put leading zeros and not trailing zeros. Trailing. And in here I no leading zeros. No leading zeros. It's a little bit different. And that's why you guys will notice that I give you guys a cheat sheet. And this is what you guys see, right? No trailing zeros. No trailing zeros. If it is less than 1, you will have to put the 0 in the front. So you have leading zeros. And you have a whole number, you will not put any decimal places. Hopefully that makes sense. When you put a dimension, you will put the dimension preferably within the dimension arrows. That will be either horizontal or vertical. If for whatever reason you cannot fit the text, you might need to do either of these two. Either you put the arrows on the outside, like you guys see here, or you can put it outside of the text. Let's say that my arrows do not fit here anymore. So what you can do is you can put the text outside, but you need to put a shoulder. If somewhere in your drawing I go and tell you, hey, you gotta put a shoulder. Well, if you have a vertical dimension that it does not fit in the text, and you cannot put the arrows on the inside, and you have to put on the arrows on the outside, even like that is way too crowded. You can put your text outside, but don't forget to put a shoulder. And again, the length of this shoulder should be about 1/8 of an inch. So you know. I'll give you guys a cheat sheet. Make sure you use it for your assignment. You have your fraction, you have your exact dimensions, and then you guys have the rounding to 3 and 2 decimal places. Okay. When you put a dimension, I'm going to ask you guys to put a datum. I think we talked about it during the lab. Make sure you look at the datum. For example, here, this guy says the correct version, but it's actually not the correct version, right? Because I need to tell you the datum. And most likely the datum, especially when you're starting learning about datum, is the left of the part. Right? So everything comes from this side. Let me see. Just like this one, right? This is the same concept. We talk about the 3/8 and the 1/4 of an inch, spacing between drawings. Do not get further than 3/8 of an inch. You can really see way too much spacing on the drawing. The second one, just kind of like keep it uniformly, so things are not too close together. If you were to grab these numbers and put them into the millimeter system or the metric system, you guys will notice this is pretty much a conversion. So if you were to do the math, you will get 6 millimeters and 10 millimeters. Stacking dimensions. Do not cross apart. Do not cross the dimensions. This is horrible. This guy is actually tells you that is the correct way, but it's not the correct way. Why? Because you're crossing here, you're crossing here, and you're crossing here. If that is the case, and you need to do it, remember you just need to follow you just need to follow your datum and don't cross apart and don't cross the extension lines. So you guys will notice that this dimension, instead of putting it here and crossing here, I wanted to put it on the other side. This dimension, I left it here, right? But now I don't have the crossing one. So you guys will notice this dimension here, I put it on the bottom, right? And everything is following my datums, but it's much, much cleaner. Nothing is crossing. When you dimension, remember that you gotta follow your datum. We'll talk about a little bit more about fabrication later on. But let's say that I want to locate this hole. Somebody will have to say, okay, so it seems to me that I'm gonna start from the top. And I'm gonna go down by 5 inches. Boom. Right? And then I know that 1 inch is from here to there. Okay, so I'm good to go. Then let's say, okay, I gotta do the next one. Oh, okay, so I'm here. What do I do? Okay, so in order to find this one, I have to go down right here. Then I have to go up. And then I have to go down by 3. And boom. So you guys will notice chasing the dimension to go here and then to go upwards and then to go downwards such that I know the location of that hole. Horrible practice. That's why we talk about, and I did an example in class, right? You guys will notice here, this guy is actually following the datum from the bottom and from the left. I think the only thing that I don't like about this is that sometimes, and I'm telling you, most of the times, you can get away from making the part as clean as possible. That means putting the dimensions on the left and on the right side, as long as you're following your datum, and trying not to cross the datum as much as possible. So instead of going over here and crossing the part all the way over here, and getting a dimension from the bottom, you can just go and do this type of dimension, which is much cleaner. Chain dimensions. Do the chain dimensions. Chain dimensions, certain holes are going to have a functional relationship. Maybe there is a bracket that is going to be placed somewhere. Let's say have a table. See, I have a table that looks like this, right? And somewhere on my table, I want to have a little bracket, right? And I need to attach that table, that bracket to that table. So it's going to have a couple of bolts, right? And what I care on the table is the relationship of those bolts to themselves rather than me. I mean, you will have a location from your big table to the location of your holes, but you want to ensure that this bracket is going to fit. So let's say I'm going to give them some leeway for them to position those holes. Nothing can be perfect, right? But I want to make sure that those holes are arranged pretty well to themselves so that I can put a bracket, right? And for that to happen, I will need to correlate those holes to each other. When you have that situation, you most likely will have a chain dimension. Chain dimension, just like to see, like the other one you call a baseline dimension, the chain dimension are pretty much dimensions that are chain or linked to each other. So like this one to that one to that one. And then usually, again, it usually happens when you have hole patterns. And this, or you have a hole that has functional relationship to itself. Like you see here, right? This is a functional relation hole. Then you will see it has the 1 inch in the middle and a 3 inch in the middle, the 1 inch in the middle and 3 inch in the middle, instead of going back to the data. When you guys have a quiz, I will let you know if there is a functional relationship between those holes. And if that is the case, if I tell you there is a functional relationship between them, then you can use the chain dimension concept. When you guys have bevels, it is kind of hard to measure angles, especially if you don't have the right tools in the shop where you work. So it is preferably measuring the sizes of the sides. But this is what I want you guys to do. Measure these sides, this one and that one, and also the height. That guy will establish the location of this slope line. I don't need to put any angle. Not that preferably. Let's say this one is kind of like secondary options. You can also put a angle, but the angle needs to be related to a dimension. This one, that one. So in order to define the starting point of my angle, I went from the bottom and then I give it the angle. I went from the left to that point and then I gave it the angle. So it is relating one feature to the other feature. Now, this is about practice because I go from the bottom to the top. I have the starting point on the angle, and then I have to move up and I see another angle somewhere else. So in order for me to do this, I'm going to have to actually do mathematics. And you don't want a machinist to do mathematics for you, right? So try to always relate the starting point to the angle if that is what you're doing, okay? This is a proper way of doing it. When you have dimensioning, most likely it's going to be on decimal places. Again, be aware of the notes. Like I will give you the notes, which is going to indicate the tolerance. If I were to give you a tolerance that it says plus minus 0.5 degrees, right? All of these dimensions should have the 0.0 in the front, right? To indicate that is one decimal place. Look at the notes and will tell you. You can also have degrees, minutes, and seconds. Degrees, minutes, and seconds, that's more like a surveying angle fold. You can also got milliradians, Sometimes they call it meals, but that is more like a military application. Most likely what you guys ever will do is regular decimal place. You will not do this stuff. But so you guys know what it is. The degree stands for regular degrees, and then the 15 minutes and 30 seconds is like if you were to grab a clock, it represents just like a clock, literally, just like a clock. In 1 degree, there is 60 minutes, and in 1 minute, there is 60 seconds. So you guys know where this one's come. Right, so pretty much what they're doing, they're grabbing that degree and they're splitting it like if it were to be a clock, right? Where one is the little one and one is the big one. And the little one and the big one will tell you the portion of the degree, like if it were to be a clock. We'll see what I got this. So if you have a radius, there's a couple of things. First of all, don't do this. This is bad. Why? Because you're crossing the part. Second of all, don't reverse my arrow. Don't do this. Let's come over here and put my little arrow. Right? This is kind of like back practice. Let's come over here, put the arrow. If you have an arrow that gets repeated a bunch of times, you can go to the notes and add one more note. The note will say something like this. Say all fillets and rounds. And what's a fillet? What's a round? So this one, let's say that's an angle, right? The one over here is called a round, and the one over here is called a fillet. And again, the one over here is a round. So the fillet is kind of like an internal round portion. So in your note, you guys will say all fillets and rounds, and you will give it the radius and put a 1 inch. That's how you will do it. And then you will get rid of all these little callouts. Now, if you gotta call it out, I believe this is the best way to do it. All right, so just come over here, point to where the radius is, move away, put a little radius. That way, you don't do this. Don't go inside of the part, don't flip my arrow. Just point to where you want to go. Boom, done. We call that Escalona Standards of Engineering. We also got diameters. Again, we're going to have a couple that I don't like. This one, we don't like. Why? Because it violates one of our rules, which is closing the parts. So do not move, don't close the part. Another one, this one is actually pretty good. It goes towards the center. I think what I don't like is this zigzag arrow. So you come over here, you put your diameter somewhere here, and you give it the distance. Right. So don't zigzag your shoulder. We're gonna do this one, go this way, go downward, with the arrow. Do not cross the part, right? So I don't want anything in the inside of the part, or keep it clean. Over here, for the diameter, for the size of the diameter, get rid of this. The incline of this arrow should be between 45, it's probably between 30 to 60 degrees. So somewhere from here to about there. That's the range that you should be able to move your angle. Don't go and give me a leader that looks a horizontal leader. Don't give me a leader that looks like a vertical leader. Don't go and give me a diameter that says something like this. No bueno. Give it a nice little incline, about 30 to 60 degrees. Put a shoulder, right? And then give me the size. Hopefully that makes sense. Who is the mute people? Gavin, mute yourself. All right. In terms of slots, you might also have slots in the drawing. You guys remember we defined the datum from the example we did during lab. Then we say from the bottom to the top, from the left to the right, from the back to the front. And again, I could change the back, the front to the back. You gotta read my instructions in terms of the datums and figure out where you are in terms of what is front and what is back. So come over here, the top, front, and side view. We did this time, this last time. We said left, we said bottom, we said back of the part, right? But I could easily go and do something differently. Instead of going and saying the bottom, I could say, you know what, let's do the top, right? And I could have easily said, instead of doing the left, let's do the right. Right? And I could have easily also say, instead of doing the back, let's do the front. And it's as simple as looking at your top, front and side, top, front, side. It's as easy as looking at your cube to find out where your datum is. I hope that you guys pay attention last. Okay, so you might also have holes. You might also have slots. The slots, the way it works, you get a mill, flat mill, a mill bit. It's just like a drill, but it's a mill that has a very cool drill that goes into the part and it starts cutting. It needs to require where it's going to start and where it's going to end. And when it goes from the start to the end, it needs to know the size and where it wants to go. For example, in here, you guys will notice that I give you the size. So somewhere at the beginning of the part, I will have a dimension that was to this one, right? And then at that point in time, will tell me my size. And will also most likely will have another dimension that will measure the location of the centers, right? Where my bullseyes are. Then you guys will notice that this one is pulling out to the whole size of the slot, and it's pulling here without a dimension. And the reason why it's not calling out a dimension is because if I'm calling out the size, which is 0.4, I'm actually calling out the diameter. And since I'm calling out the diameter, I know that this distance here is 0.2, and this guy is 0.20. So as you guys could see, that distance is the same as this distance, right? Which is the radius. So I'm not going to be calling a radius, calling it here and calling it there. Because remember, your nodes tell you plus minus certain tolerance that is allowed. And if I were to go and I were to call out the radius here, that means I have a call out here, and I have a call out here. You're telling both of them like 2 times, right? And I also have a call out here, which might not be what you want. You either call the diameter or you call the radius. For example, here I call the radius, which means I don't call the diameter. In here I call the diameter, therefore I did not call the radius. In here I got in the size, right? And since I got in the size, I also know where the bullseye is. This is 0.4, that means this is 0.2, and that is 0.2. So I can figure out that from 1.2, take away 0.2 and 0.2, and I will give you my bullseye. Hopefully that makes sense. Again, all of the examples that I have given you, and again, this is wrong because it doesn't have a shoulder, it should have a shoulder. You can also call out the slot by coming over there and give it size. Let's say my size is 0.40 by 1.2. What does that mean? That is from here to there. Boom. And in this case, this one is the diameter. And since I know the diameter, I don't put a value for the radius. You either do one or you do the other. You don't do both. Remember, the features are dimension where the features are. You dimension the slots where the slots are. You dimension the holes where the holes are. You dimension the notches where the notches occur. You dimension the thickness where the thickness occur. You don't do this thing mentioned over here, right? Don't go and say, okay, remember, you start from the bottom to the top. The first dimension that you will see will be this one, not this one. Why? Because on the left side, I don't know if that thing is oval or maybe it's spiky or what it is. The view in here, in this case, the right side view, is telling me that I actually have a notch that I need to take care of. Reference dimensions. What do I mean with reference dimensions? Certain times when you dimension things, see over here, and I have a part that looks like this. Right? And somewhere on my drawings, I put plus minus 15,000, right? Because tell me my allowance, my tolerance. Or what do I do in terms of sizes? I could have, let's say that this guy is 3 inches, right? So I come over here and I type 3.000. And then I come over here and I put a chain dimension, right? And I put 1.00, 1.00, 1.00. So in this case, I have this dimension, which I have completely the chain, so I know the whole size, and I also have this dimension, which is also telling me the size. This guy on the top is telling me plus or minus 15,000, plus minus 15,000, plus minus 15,000, while the one on the bottom is telling me plus minus 15,000. And you're wondering, which one do I use? 15,000, or I use 3 times 0.015, for the plus minus 15,000. When the top one is giving me 3 times tolerance accumulation, which what we call it stack up, the bottom is not giving me total accumulation. You are giving now the option to the machinist to give me 15,000 up, or having more leeway to accumulate the distances, accumulate stack ups, because things can grow. Everything could become bigger, or everything could be smaller. So you do not make the machining confused by providing top and bottom. Internet forest. Sorry guys, the internet here is not the best. Thank you, Dr. College. Let me clean myself. Alright. Hopefully that makes sense. I don't know. Again, if you guys miss anything, let me know in the chat. I'm looking at the chat. So if you, for whatever reason, you want to give it the third dimension, or you just want to let them know, instead of doing all of this, what you do is you do something that looks like this. Come over here. You can give it the overall size. Actually, that would be a good idea, 3.00. You come over here. You give it the first two. And the last one, if you want to give it to them, you put them on parentheses. And that parenthesis is pretty much telling you the last one is for you to know. It is for reference. And the way you let them know that it's a reference dimension is by putting a parenthesis. Simple as that. Okay. And let me see. I believe this is what I was telling you guys about. This is the parenthesis. You don't put the circle. You just put the parenthesis, and I think that's it. Do not double dimension. Remember, when I show you guys how to dimension, I tell you go from the bottom to the top, and you decide where to put the dimension. It only goes to one place. If you go and you have the depth, which in this case is the depth, this is the case for this one, the depth can be seen on the top, and you can see on the side view. This is the depth, and again you can also see it on the top view. Depth. You guys will notice that this drawing is showing it in the side view and it's showing it in the top view. You only show it once. Why do you show it once? As a rule of thumb, is because you want to avoid conflicting tolerances, where one is telling you something and the other one is telling you something else. Hopefully that makes sense. Once you guys put all together, you guys should have gotten something similar like this. And I think it's something like what we did in the example during lecture. Actually, there is something that I don't like about this. I'll tell you why. When you go and you're grabbing the dimension, there should not be, the only gap that should be here, you have the bullseye, right? There should only be a gap right there. And again, because what you are trying to graph and have the extension line to, which is the extension line, is to the bullseye. So there should only be the gap right here and the gap right there. Which is what you guys see here and see right there. So this one gap that you guys see extra, that one shouldn't be there. So you guys know. Remember, it's 1/16 at the end, about 1/8 of an inch. Your arrow should be a 1:3 ratio. The size of your arrow should be 1/8 of an inch. Your first dimension should be about 3/8 of an inch. The next dimension should be at least 1/4 of an inch. No dimension should cross the part. The number of decimal places that you place in your general note should be the same number of decimal places that you put in your drawing. You put all your dimensions to be horizontal. You choose the datum based on function, which most likely I want to tell you the datums. And then you go from the bottom to the top. Thickness, height. In the one that is missing here, you should put it 2 times because you guys have 1 feature, 2 features. Then you go to the left side, which is the blue that you guys see here. You go to the home, you to where the notch belongs, you go to the thickness, you go to where the notch belongs right here. You got the overall width, and then you go from the back, boom, 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 to the hole, to the overall depth. And you call out the hole. You put your notes. Usually the notes go either on the bottom right corner or the top right corner. But since we usually have an isometric view on the top right corner, we usually tend to put it on the bottom left and bottom right. Don't forget to put the title block. You need to know what you made it out of. You need to know how many you need in your assembly. You need to use your scale, who drew it, the date, the title, and you also will need a revision schedule. What's a revision schedule? So find one up. Google revision schedule and clouds for mechanical drawing. And the revision schedule and the cloud, it is not necessarily for mechanical drawings. You do it everywhere. So for example, the one that you guys see here, every time there is a change and there is an iteration between design and whoever is approving these drawings, every revision will get clouded. You see this like a cloud, and that cloud will have a little triangle, and that triangle has a number. There will be a table that will have those numbers, and it will have the date, and it will tell you what was the change that was made. There is a track that you gotta keep on the drawing so you know which revision you're on, and the way you track it with clouds, which are called revision clouds, revision numbers, or the ID, revision ID. And then you put it on a table, and then this is what you guys will have to have here. Somewhere in there, you will need a table. It's likely the table will somewhere here on the left side, and we'll have a revision ID, date, and description. And then whatever change, you come over here and you cloud it, and then you give it a little arrow. It's called the revision 1. You put over here the arrow 1, you put the date, and then you put what you change. Oh, I made it, I don't know, something. We don't do revisions in this class because I don't give you iterations of drawing. You submit it once on it. Probably I should start making revisions. Huh? Okay, I believe this is pretty good. Cover up on all the basic dimensioning. I would really suggest you guys review the videos that I posted. The one that we did here on the lab when we did the assignment. Also double check this video that we went over all the rules. And then you should be good for your quiz. All right. I believe this is the time that I'm going to stop my share.